Let's talk about the instructions call and return. Now these instructions will also change the flow of the program. For example, see this. What I mean to say is call and return. So these two instructions, they fall in the category of that control instructions, program control instructions. Assume that your program is going in a sequential flow and suddenly there is an instruction at address 100 and the instruction is call some subroutine, okay, calling some subroutine. Then because of this instruction our program has to go to some other subroutine and it has to execute that subroutine, and at the end of the subroutine there is going to be instruction return, and as a result of this instruction return you are supposed to come back to the instruction 101 and you are supposed to start your execution from here. Now if you see this, it is actually affecting the flow of the program. That is why this return and call, these two instructions fall in this category of program control instructions. Now the main thing is, even though they are single instructions, in order to perform this we have to perform many operations, right? So what are the various operations you will have to do as a result of call instruction is, maybe you can guess it, right? See, now if you are in 100, if you are going to some other program location, let us say 1000, now again you have to come back to 101. One thing is for sure, in order to go from instruction number 100, by the time you fetch it and by the time you execute this instruction, already program counter is incremented to 101, right? Later when I show you about various phases, I'll tell you how it happens, but now assume that by the time I execute this function, this instruction, our program counter is already containing the 101, which means automatically the next instruction that will be fetched will be 101, but then you should stop it from happening and you should load the instruction from address 1000. So what should happen? One simple thing that should definitely happen is, when you are trying to do this, when you are calling this sub, program counter should be loaded with the effective address of that function, right? So therefore, even though 101 has to be here, it has to be loaded with 1000, right? Now the problem with this one is, once you load program counter with 1000, once you are here and if you start executing, this address 101 is permanently lost, isn't it? The only pointer which holds 101 is program counter. Now once you overwrite it, it is permanently lost. Therefore, even after you execute this entire function, we don't know where to return, right? So how can you solve it? How can you solve that this problem? So one way you can solve that problem is, you can say that you can supply this return statement with the address 101, isn't it? Therefore by the end of this program, this subroutine, you automatically go to 101. But the problem is, it is not always guaranteed that you will call this sub function from address 100. In case if you are calling this subroutine from the address 100, then having 101 hot typed, or having this address typed into this program is meaningful, isn't it? But next time when you call it from, let us say, somewhere at 200, if you put this call 200, the return address should be 201. It is not 101, right? So all the time whenever it is called, you are not supposed to go to 101. So how can you solve it? So one other way of solving it is, before you overwrite this program counter with the effective address, try to save this address somewhere, right? And various strategies have been used and various ideas have been proposed since the invention of this computer. Various strategies have been used. So what are various strategies is, some people say that you copy this contents into some other register, program 101 into some other register. Let us call that register as some temporary register. You copy this first and then load it. Later when you execute this return is going to load back this 101 into this one, and that is how you can continue your program. Got it? So that has been used long back. And some other people say that you copy this into front part, or you copy this at some point in the store it at the memory location which is already storing your function. So which means store it in the subroutine. Storing it in subroutine doesn't mean that you have to write some code there. It means that wherever in the memory, let us say this is the memory and this is the subroutine part, and the subroutine is occupied from 1000 to, let us say, 1020. Then you leave some space before every subroutine so that this space will be written with the address in the memory. Got it? So in this place 101 will be stored, and while returning, this return address will copy this 101 to the program counter. Therefore you can continue with 101, right? And then some people say that you can store it in a fixed memory location, not in the subroutine. You can store it in a fixed memory location, right? Either in the first address or in the last address. So some memory will be always be reserved so that you can store the return address. Let us say some memory 00H, which means this starting address. You can reserve it. Nothing is wrong in that, right? And the best method proposed till now is to store it in the memory stack. Memory stack. So why is it the best method is? Let's talk about a scenario where you have called this, okay, and now suddenly this program at some point, this subroutine wants to call some other program, right? And again it has to return back to here, right? Now again this subprogram has to save this return address, isn't it? Where will it store? In case if you are using a single register, you have already stored that single register with the return address 101. Now you have to store this with, let us say, 1005, right? Now you have to save this return address also on this register, which means the old return address will be lost. Therefore using a register will be okay, or it will be useful only when you make one function call at a time, and after finishing that function call, then only if you make the second function call, then it is going to work. But then if a function calls other function, or if a function is using recursion, which means if a function calls itself, then this method is going to fail, right? So it is not very useful. It is simple, not useful. And the same rule will apply for the subroutine as well. Even if you are trying to store it in the subroutine, maybe if you are calling two different functions, it will work. For example, if you are calling this function, then at the beginning of this function you can put the return address. Next, when you are calling some other function, at the beginning of that function you can put 1005. So it will work as long as a function is going to call a different function. But then if a function calls itself, then the problem is it cannot keep on storing many return addresses at the same location. Why? If a function is calling itself, then all the return addresses should be stored in the function itself at the beginning of the function, and we have limited space there. So even this one will fail. For the same reason, fixed memory location will also fail. Even if you are talking about fixed memory location, we cannot write more than one value there. So only interesting thing is memory stack, right? So in case if you are using a memory stack, that is the best method. The reason is, even if you are going to call many functions, every function address can be stored in the stack, isn't it? You can have a stack and you can have a pointer, right? So on the stack you can put it. Let us say the stack pointer is represented by SP, right? So what you do is you can say memory location. In the memory you are implementing the stack, memory location of SP. Into this you can copy the contents of program counter, and you can do SP++. Got it? Therefore when you are applying the call, so when you are calling the call instruction, the operations that have to be performed is, first thing is memory location has to be loaded, this stack, right? The stack in the memory has to be loaded with the current value of program counter, which is nothing but the return address, and then the stack pointer has to be incremented. right? And then after that you have to load the effective address of the function into the program counter. Program counter has to be loaded with effective address. What is effective address? The address of the this function. Got it? That subroutine. And what will return address do? While you are returning, you have to go to the, you have to pop up the value and you have to get it. So you have to decrement the stack pointer, and then you have to go to the memory and see the location pointed by the stack pointer, get it and load it into program counter. Got it? So this is how you can deal with the calling and returning. Now this might get bit complicated sometimes. So this is the simplest way, and this has been used initially. Now with the modern programming languages, the problem arises when the functions want to communicate. For example, if you want to send some information from here to here and then get some information from here to here, right? That is called as parameter passing. Now when you want to send the parameters and get the values, then you have to use the same scheme. This one will be useful, right? But with some minor modifications. What happens is, our stack is not just going to contain the address, it is also going to contain some space for the operands. For example, our stack is going to contain records. They are also called as activation records, and they will contain various parameters depending on what you are trying to achieve, right? So one important parameter is nothing but the return address, okay, and the other important parameter is nothing but what are the actual parameters and formal parameters, right? You can say what are the formal parameters and what are the actual parameters, right? So what happens is, whenever you are trying to call a function, before calling that function, when you execute that call, all the parameters will be loaded, and then the return address will be loaded, and then that function will be called. While returning, the return function will just write the return values that have to be returned in the parameters field, and then it will return the control to you. Anyway, that is out of the scope of this topic. So the basic functionality what call and return has to do is this: it has to store the return address somewhere and then get it back. Okay, now what about the status of the processor? Should we save it? So what I mean by status is, sometimes it is also called as context, right? I think you must be remembering that word context switching in operating systems. So whenever we switch a process from one process to other process, we are even supposed to save the context. But within the same program, if we are changing from one function to the other function, the program itself is responsible for this calling. Therefore the program itself should make sure that after the function calling is over, it gets back to execution normally without saving any status. So what I mean to say is, see this, let us say before this function call is being made, assume that our processor is going to have various registers, R1, R2, R3 like this, R1, R2, R3 like this, okay. Now some information will be present here. Now my question is, should we even save the information present in these registers before going to the function call? I am saying no need. Why? Because why should we save it in other contexts is, when you are switching from one process to other process, you should be saving it because it is occurring because of the external events. A context switch will occur because of the external events which are called as interrupts. And now our program doesn't know that such an event will happen, therefore it will not take care of it. So what happens is, maybe if you write a equal to b plus c, okay, b will be loaded in R1, let's say, assume that, and c will be loaded in R2, just assume this. Now our processor will try to add R1 and R2 and then try to compute a. Got it? Now after loading this R1 and R2, let us say the instructions are like this: load B into R1, load C into R2, right? And then maybe the next instruction is add R1 comma R2, which means add R1 and R2 and store the result in R1, something like this. Now assume that after these two instructions are executed, there is an interrupt here. What is an interrupt? We shall look at it shortly. Or you can think that after this instruction is over, let us say because of some reason your program is stopped and some other program is run. Then what happens is the other program which is allowed to run might change these registers. Then after this program is resumed, the present program is resumed, then it will try to use the contents of R1 and R2 which might have been changed by the other program, right? In that case we are supposed to save this status, right, or the context. Along with the registers, we should even be saving the program program status word as well, because the program status word flags might also be useful for you in the next instruction, right? Therefore when you are changing the process or the program because of some external event, you are supposed to take care or you are supposed to save the context. But then when you are changing the program flow because of the internal events, since this program itself is calling some other program, it will never try to use the registers which have been used earlier, or in case if it is going to use those registers, it will not use those registers here. Got it? Therefore program itself will take care. So main things that you are supposed to save here is return address. You are supposed to save the return address in the stack and then get it back, right? You need not save the program context. And where are you supposed to save the context? Whenever your program is going to be affected because of the external events, right? So we shall see what those events are, how they occur in the next one. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.